Так, друзья, у всех свободные руки? Давайте с аплодисментов войдем, как будто мы телевидение прям настоящее. Moscow Python продолжается в парке Горького. Вышло солнышко. Друзья, как тепло, как хорошо. И сейчас я представляю бразильца, который ненавидит футбол, перед русскими, которые ненавидят водку. Поехали, друзья. Pablo, please. This is the time. We will welcome you on the stage.
Thanks. Yeah, it's working. Yeah. So like guys started here. So my presentation is called Types Beyond Any, but I mean kind of approach here type-driven development. Just like a resume about me. Like my name is Pablo Aguilar. I'm from Brazil. I'm really like functional programming enthusiast. I'm one of the Dry Python core developers. So if you don't know Dry Python, pay us a visit there. So what's a type, right? When you just start talking about typing or when learning a new language, like type is just a type, like just use it, you know. But that's not wrong, but it's not right as well, because in fact, a type is information, and it's information about the boundaries of your data, right? So like this one, like every type has its own boundaries. So I have int, I have float. I can even constrain my new types like that one inside int. So basically types change the way you manipulate the data, change the way you see the code and the code flows. So just a little example here. You have that binary sequence there, which when I add the string type to them, I have the A letter. But if I say that binary sequence is in fact an int, it would be the number 65. So let's talk about now type as a promise or intention. So making our intentions more explicit in your code by using types. So the first example here is just a function, normal function, with its for div. So it takes two integers and return one integer. Right? Nothing much here. And OK, yeah. So if I try to divide like 9 by 1, I get 9. 5 by 2, I get 2. 0 by 2, I get 0. And 6 by 0, I get what I get? I get an error, because it's impossible to divide like any number by 0, right? So how can you approach this, like using types instead of like just a random exception? Well, you need to talk first about functions, and functions can be partial or total. Basically, a function is total when it works for all its input. So everything I put in calling my function, it works. But my function is partial when it doesn't works for all the possible inputs you have. So what you can do in this way to get a better code, a better approach. So you can leave as is, and like the user just handle the exception. You can verify if y is 0 and raise a custom exception, and like the user can know the exceptions come from our code or our library. Or we can make our type more explicit, which we're going to do now. So you're going to create a new type to reduce the scope. So what type we're going to build here is one to make our function total. So this way you're going to restrict any 0 from our code. So yeah, think about you have the int space. I'm creating a type inside the int space where 0 is not contemplated there. So yeah, the first approach would be like type alias, because type alias can give us some context about the data you are dealing with. But type alias won't work for this case. And if you know what is a type alias, you can see here like non-zero int, like is just like a variable assignment. But you put the type annotation, you assign a type annotation to that variable. So here I just like changed my y from int to non-zero int, and I have my for call, normal call. But it won't work because when you have a type alias, both types are equivalent, right? So my non-zero int, it's already an int. It's not a new type. No. So yeah. So let's create a new type by using the typing.newType from the standard library. And here, we're just importing new type and creating our non-zero int type. And I'm bounding to int. So basically, I'm saying, hey, this non-zero int type is bound to int. It is a really new type for the type checkers. And y remains non-zero int for our type annotation. So now I'm just calling my for value with value of 10, and like maybe think like this is gonna work, but it doesn't. By the type checker on runtime, it will work well, but for the type checker won't. You got this error here, which says, hey, argument 2 to floor div, which it's our y parameter. It's is receiving an int, but expecting a non-zero int. So how you can transform our int in a non-zero int? You can have two approaches here. The first one is using just a type guard. And if you've never heard about type guard, I'll show you now. So basically, I can declare a function, in this case is non-zero int, where I'm receiving a val, which is int. And the type annotation here is type guard non-zero int. That means that if the function returns true, that type is non-zero int. But if it returns false, it's just an int, right? And the way I can like transform my value of 10, which is int, to a non-zero int, I can just like write an if statement, like if is non-zero int, pass in my value. Automatically, you're gonna have like the value of int converted to a non-zero int inside the if statement scope. So while you are inside the if statement, we are going to have our non-zero int value, so we don't have like any type checker error right now. Another way, I can just like instantiate it like a normal class. You have just like non-zero int, and everything will work fine without like any modifications. But no error this time. But you got the same problem again, because I can declare my non-zero int, I can instantiate my non-zero int passing the zero value, right? So how can like overcome this problem again that I have? Like I've already created a new type for that to not have that problem, right? This is why I'm going to talk about now phantom types, and I'm just gonna say about a specific implementation of phantom types, a phantom types library for Python, So phantom types basically doesn't exist on runtime. It's basically I can create a type like for an int, for a string, and on runtime it remains int and string. But for the type checker, you're gonna have some information, some additional information for checking. So yeah, that's the library I'm going to use, phantom types. Yeah, and the way it's work, it's very similar that the things you have down here. So yeah, my is non-zero int functions remains the same. I just changed the type annotation return from type guard to Boolean, because I will return a Boolean right. I'm creating a new class, and the first parameter of this class decoration is int. So I'm telling that my non-zero int class is bounded to the int scope. The second argument is phantom, like it's just a class from phantom types library. And the next one, I'm setting a predicate. So a predicate here will check every time you're gonna like instantiate that type if the predicate is being respected. Yeah, so my for du functions like remain the same. My y arguments is non-zero int. And okay, and for use that type now, you have non-zero int dot parse to get the non-zero int. So basically, the parse function will run all of my predicates to see if like everything is working correctly. And if I try to parse a 0, I got a parse error. And it seems kind of like you create a bunch of stuff and end up with the same problem again, because now I'm going to raise an exception if the value is 0, as same as I was dividing when I was dividing, right? But the thing is, when you are casting or you are getting a more specific type, you can get more features, or you can reappropriate that type in other calls. Like this one, in this example, I just have my for function. I have code before the for function, and I have code after the for function. So, but thinking that for function can be any other kind of function, a more complex function. So once I have my non-zero int, I can spread all of my code, and I just need to parse and check just one time. Yeah. Okay. And show you how phantom types is gonna work, as well as new type for the typing library. I'm just gonna print out the type of y, the type of y plus y, and the type of y plus x plus y. Sorry. And also try to assign an integer to my y, and try to give some addition and y plus 1. So yeah, that is the output, as you can see. So just y is non-zero int. But when I try to change my y argument, my y parameter, somehow adding or reassigning, reassigning him, you got the int again. And why you have the int again? Because you can assure that type remains strictly as it should be. So because I could parse the value of 1 and just got -1, so I got 0 again. So there's no way the type checker could ensure us that everything is going to work. So this is why you lost the information about the non-zero int, and you get our int again. And if I try to assign, here, I was trying to assign 1 to y, I got an error, because my y is non-zero int, and my 1 is just int, right? Okay, so for that implementation of phantom types, the parse method is the only way you can get the type. No, it's just instantiated. Okay, so basically, typing versus new type, new type versus phantom types, it's basically the same. But what the difference here is the later you're gonna parse the data, you're gonna validating the data, right? So both approaches are good. It's just a way to change what you really want in your project or your structure. So everything I've said so far, I can say it's about not having an illegal state in our applications, in our domain. So let's talk more about legal status. Okay. And I'm going to talk here about algebraic data types, or ADTs. And you have basically two types of algebraic data types. You have sum types and you have product types. The first one, sum type, I have an example here about a difficulty level. Okay. So say you have this function here with say difficulty level, which receives the level, and in that case, the level is just a string, and I'm turning on and pattern matching level the string. So in case my string is newby, I'm just gonna print that is easy, and if my string is average, it's gonna print it's getting hard. So far, all good. I think you have this code in production. So yeah, so say diff level, if I pass me by, that is easy. But what about if I pass something that I don't expect, like awesome? Well, you don't get, like, won't work, you won't print anything out. And how can ensure that our function will always work for the inputs? You can create a sum type. And this is a sum type in Haskell. So basically, the difficult level is a type name, and the newBy average will be our type constructor. And you can say, hey, this is something that I have seen, which is basically our enum. I can say, like, for now, let's say the sum type will just be an enum. So I have my difficult level, which is newBy and average. And now I can change my type annotation from level, from str to difficult level, and pattern matching just like using the enum members here. OK, but what about I add another member here, like I'm adding hi? What's going to be printed out? Yeah, well, nothing. But using some types, and specifically using a type checker, we can, you can guarantee that every time I add a new member or I change something, I'm going to type error because I need to look into it. So yeah, you can exhaustive check. And the way you can exhaustive check using some types is basically importing a certain error from the typing library and like add a special case, a default case, in fact. So case as unreachable, and I'm passing just the value of the unreachable to a certain error. And that will be enough. So when I try to type check, again, I got an error. And here say, hey, a certain error has incompatible type, difficult level high, expecting no return or no value. So this means that I have a missing case in here, with my difficult level high. So once I add my another case for high, the type checker just worked, and I don't have any errors anymore. And so let's talk about now product types. So the example here is about a speaker paper. And basically, OK, the Haskell example, which has a speaker paper, which is my type name. I have my type constructor, which is named in Haskell. That's why I'm speaker paper and speaker paper, because the later is my constructor. And I have my constructor parameters, which can be string, will be a string, difficult level, bool, and maybe datetime. But you can get better just to know what is my types. I can use this syntax over here. So my name is a string. My difficult level is the difficult level we have approached. It's approved. It's a Boolean. And my presentation date may be a datetime. So you can have it or not. So yeah, that's just a normal class in Python. And here I'm just using data class to shorthand init functions. And so, yeah, and you have the same attributes here. So have name, string, difficult level is approved, a Boolean, and presentation 8, maybe at a time. Here I'm using maybe a container from returns. So if you don't know returns, go check it out. OK, but what about the illegal states are talking about? OK, now you have set what is the sum type and what is product type. And you have an example, a speaker paper example. So let's say that an unapproved paper doesn't have a presentation date. So it shouldn't have, because it's not approved yet. But when my presentation is approved, I should have a presentation date, right? So right now, there's no way that you can avoid illegal states by talking about type. So here, it's an approved paper, but has no presentation date. So it's an illegal state. And the other is also true. I have an unapproved paper, but I do have a datetime setting. So how you can work around to avoid that illegal state? Yeah. So you can join some types and product types together to build that out. Yep. Okay. Okay. The example in Haskell we have. So now you have the same speaker paper data you have previously, but now you have two different type constructors. So one is for approved paper, which is like a name, just string, difficulty level, and my approved paper now has my presentation date not being a maybe, but in fact a type. So I need to fill that that field when instantiating. And like when I talk about some types, I say, hey, some types it's enum, but in fact I would say that enum is just like a subset of some types. Well, you have tagged union, so tagged union from the win, but basically tagged union is the same as some type. Like if you search for tagged union, you're gonna find some type stuff as well. So how it's gonna work right now? So this is the same you have in Haskell, but now in Python. And let me explain. So now you have it splitted our only class and two classes. So now I have an approved paper class and an approved paper class. Okay. By the way, the is approved attribute was removed because like the class speaks for itself, right? So, okay. And now I'm going to create a type alias for which is speaker paper, and using the union type. If you haven't heard about union types, it's basically I can say, hey, this variable here can be this type or other type. So here I'm saying, hey, speaker paper can be an approved paper type or approved paper type. Okay, the first declaration is a new syntax you can use, but like if your Python don't support that, you can just import from type in union. Okay, now I have my announce paper function, which is I'm just pattern matching here. So I have my paper, which is speaker paper, and pattern matching to see if like it's an approved paper, and also exhaustive in check. So yeah, you're gonna get an error here because we're not pattern matching when it's approved. Okay. So yeah, I just added the approved paper case, and now everything are working, everything is done. But just remind that now you don't have like a way to have a legal state because you have now two separate classes, one for approved paper, another for unapproved paper, and the approved paper one, I need to fill the presentation date gap. So yeah, what do you have so far? So you have explicitly conversions between your states. So instead of you just like setting a Boolean flag to see to tell if that it's approved or not, now we have typing saying for itself it's approved or not, and also we can exhaustive check because we are using union. So yeah, if you don't like want to pattern matching, or your Python version don't support pattern matching yet, or you don't want to like make a bunch of if statements using isInstance, there is another way you can like use tagged union, which is basically adding a tag to our classes. So yeah, like a tag can be any information if you want, or you can like add a specific attribute like tag attribute for your types. But here I'm just going back with is approved, and now the type for is approved is literal. So for unapproved is literal false, and for approved is literal true. And literal enforces to always use the value you have set. So there's no way I can like put true and is approved for unapproved paper, and the same for approved paper. So yeah, that also ensures that like you don't have an approved paper with invalid state. And I can just have like if paper is approved or if not. Oh, by the way, I'm just adding this if not here. I know it can be just an else statement, but I just wanted to show that you can also exhaustive check even using if statements. So yeah, if I remove the elif not part, paper is approved, I'm gonna have an error because I want to exhaustive check that. So yeah, everything I've talked about here is about domain or how we can modulate our domain. But what about the things that is outside our domain? Like we're going to store your data, right? Or your database, or you're going to make an API call. Yeah, so what about the rest of the plain world you have that doesn't know about some product types? So thinking about this structure here, in memory database was just using a dictionary. So yeah, now I have my name, the same class I had before that can have an invalid state, but this is just a point where you're gonna save the information, the data. Okay, type classes. I'm gonna show you type classes right now. Type classes. It's like an interface. You know, it's like a protocol you already know in Python. But it's not implemented by a type, but it's implemented for a type. I'm going to use classes here, which implements type classes for Python. Just a basic use case here. So yeah, I'm importing type classes. From classes, I'm just using a decorator in my function, which is called save2db. And this time here, save2db is my type class, is my interface, right? So it just receive a model, which can be any here, and return nothing. So yeah, and to use or to create an instance of a type class, I can just use my save2db function as a decorator and pass in an approved paper type or an approved paper class. So here I'm saying, hey, I'm creating an instance for an approved paper. So every time I call my save2db with an approved paper, this function will be called. And here I'm just hard coding is approved to false because I know it's false because it's an approved paper, and my presentation to none. Yeah, and the same for approved paper, where my is approved will be true, and my presentation date is my presentation date that I already have. And yeah, you can like do the same thing without type classes. I just want to show another way you can do things. So without type classes, like you can just have save your paper, and for it's approved, I can check if it is instance of approved paper. And to get my presentation date, I can just use the get attribute. Trying to find the presentation date attribute. Yeah. Okay, I'm not gonna deep dive in security with types, but it's something that it's worth to know, right? So you can have some security things using Python. The first, I think, like its most basic example you have, which is literal string. I get this example from the Python documentation. So yeah, you have your function, which is run query, which receive a SQL, which is a literal string. So let's find out what is a literal string, right? So the first call to run query is just like a string without any like formattation things like a format or dot format. So it is a literal string. A literal string is basically something that was not chained by like human interactions or this kind of way. Okay, my second call, like just literal string, which is already a literal string, so I get no problem here. My third call, I have changing my string, but I'm concatenating a literal string with a literal string, which is acceptable. So if both are literal string, I'm gonna have a literal string back. So that's okay for the type checker. And when I try to pass just like a string, like in the fourth call, we're gonna type check error. And like if I try, as I say, to format a string, you also don't have like a literal string. I think like the best scenario I can show is this slide, because it can be like avoiding, or like SQL injection. I know that's like it's a very known problem that you already know, but sometimes I see people just not paying attention to that. So like the type checker can help us here. And also you can track sensible data using types. And here you can use Pisa. Pisa is a part of PAR, and PAR is it's Meta's type checker. Yeah. So basically, you can say, hey, this is my sensible data, and this is the locations I don't wanna like in print statement, login, and kind of thing, and they will check all the flow of the sensible data in your code to avoid you like to print your password or print a secret key or any sync you have to the world. So yeah, concluding here. So everything here, like, it's all about business domain, right? Because you need to have a concise and precisely designed a business domain to work well. I'm not saying like, hey, you should not like have legal state, or you should do the things I have shown to you. But it's cool when you have something well modulated, well documented. Okay, type checking doesn't mean the bugs will not appear, right? Even type checking, you need to like write your unit tests, your integration tests as well. So yeah, there's no silver bullet, right? And also types like provide a clear and a concise way, explicit way documenting the code's behavior. And also enables easier refactoring. Like if you have moderated your types well through your application, it's really easy to refactor. Like I have worked some application that just using dictionaries. So in the type notation was just dict str any. So yeah, you don't know what's going there. Yeah, here is just something like a recommendation if you want to check with beer type. Beer type is a runtime type checker. It's worth a view. So yeah, thanks to Moscow Python Conf, and also thanks to Positive Hack Days for having me here. And a special thanks to Alexios, Bruno Delfino, and Nikita Sobolev for working with me in this presentation, and also Paulina. I don't think she's here, but yeah, he helped me a lot to get here in Russia. Check out all the things. So yeah, if you want to read, you have some links here. I really recommend the four links here, the first. Yeah, спасибо. Read this presentation, please.
Thank you, Pablo.
Yo.
This is the big difference between Russian speakers and non-Russian speakers. Russians never say thank you personally to people who do anything. But we'll change soon, I promise you. So, questions?
Hello, I'm Denis from Raiffeisen Bank. You know me. Very impressive speech. Thank you. I enjoyed it a lot. Haskell references was top, in my opinion. I have some question partially related to your topic. How do you think is our current typing state is mature enough to be compared to statically typed language like Java in terms of reliability, resilience, and so on? Thank
Yeah.
you.
Yeah, sure. Yeah, I think that the most like opinion I can have here, like you won't have like typing things like Java because because the Python like the Python ecosystem and the Python essence, like dynamic in things. But yeah, like I don't know about reliability because everything is just information. Like typing, when I add type annotation is just information. You're gonna you don't gain anything at all. It's just like for type checking before you run your code and put your code to the production. That's answer your question?
Any more questions? Good. You can ask them personally after this one. And then you choose who gets the prize for the best question.
Okay. Oh, by the way, if you want to have me in touch, just drop me a message on Telegram. That's my username. If you want.
Hi, I'm Eric. I wanted to ask you, did you try to use Pydantic library? And if no, maybe it is related to some performance issues, etc.
Yeah, I have used Pydantic, and I guess like the last release, you have like a really improved speed because I think they write in Rust. I guess I don't remember. But yeah, I have used it. I think it's a good tool to have. And the why I have shown beer type is just because like everyone's know Pydantic but doesn't know beer type. And beer type is actually I guess a good replacement maybe because the complexity to check the type and runtime for beer type is all of one.
Because I think that validators in Pydantic is a really cool thing.
Oh, sorry, can you repeat, please?
Yeah, because validators that there are in Pydantic very cool thing. Did you think so?
Yeah. Like I think Pydantic starts just like to type checking on time and have become maybe a really validator library right now.
Thank you. Вот рядом прям. Ага.
Hey, hello. Thank you for your presentation. I never heard of phantom types, so I want to ask a question. How do they work with static type checkers like MyPy?
Oh yeah, the examples I showed. I forgot to say that, but all the examples I showed here, I have used MyPy to type check. So all the error messages was done with MyPy, and like it's just like MyPy has extensibility. So phantom types can, I guess phantom types has like a plugin for MyPy.
So they have stubs for that.
Sorry?
So they have stubs for phantom types.
Stubs?
Stubs.
Oh no.
No. Okay.
More questions? Закроем цикл.
Thank you. One more question. What do you prefer, MyPy, Pyrite, or other type checker? What do you recommend to fellow Python developers?
Yeah.
Thank you.
MyPy for sure. MyPy for sure. Like even like MyPy is from Python Software Foundation, so I think it's already a good thing. But maybe Nikita can say something later about MyPy. He's a MyPy core developer. But yeah, but I really recommend like MyPy because it's mostly used right now. Then like Pyra, which I don't think everyone's outside Meta uses Pyra or Pisa. And Pyrite, like I don't know, it's just it's there, it's somewhere there. But I really recommend MyPy.
And one more question. Because we have time, and it's good.
Yo.
Nice.
Oh,
We actually
hello.
have 10 more minutes for questions.
Yeah, please. Thank you for your speech. I wanted to ask you, what do you think about gradual typing? I mean, you want to insert types everywhere in your code, or you prefer insert types if you need this in this case?
Sorry.
So you insert types everywhere in your code, or in different place if you really need this in this place.
So I couldn't understand. Can you please?
How often
Sorry.
how often you insert types in your code? Every variable, every function in your code has type,
Got it.
or not?
Yeah, like I prefer like if I have a project, If I start with typing, like I put typer everywhere. But like if it's just like a project that doesn't need type, I not do partial typing, you know. So or I add or I don't add types. Is that answering your question? Yeah.
So, Pablo, who gets the prize for the best question?
Yo. Yeah.
Take your time.
It's one prize.
Yes, one prize.
One prize. Yeah.
The rest will
Or-
just get the free coffee. Yes.
That's. I guess that over there.
Okay.
Yeah.
Thank you. We also have a souvenir for you, personally. There it goes. And it's really good to have you here.
Oh, thanks so
Thank
much.
you for coming.
Oh,
Nice.
It's for.
Thank you very much. It's for you.
Oh, thanks.
We hope that you will see Moscow City with the sun and beauty, and
Great. Yeah, I have seen that.
hope it will
yesterday.
be good to you.
Yeah.
Thank you very much. Have a good conference. Ну что, прошел мальчишка, да, собеседование в Райф? Вот. Нормально.